Okay. So I'm going to talk about building a REST API with CakePHP. So just a quick plug first, I work for a company called WizeHive, and what we do is there are a lot of companies who have generic project management, like Basecamp, Dropbox, Trello. And then you have data collection, Wufoo, Spreadsheets, Salesforce. What WizeHive does is it kind of bridges the gap between data and collaboration. So you could bring in data and then collaborate with a team around it. The reason it's important that I mention this is because WizeHive has been around for a few years, doing very well, but we wanted to broaden out the base. And part of doing that was building an entirely new platform in the last year. So we decided to build a back-end API and a front-end Angular app. There's also a mobile client, which sits on top of PhoneGap and also talks to the API. So I wanted to start off with a quick misconception. I know I was guilty of it 2 or 3 years ago. When you build out a REST API, it's really easy to get into this mindset that CRUD is simple, models are simple, and so all an API is doing read, create, update, delete operations to those models. The problem is that there's a lot of input and output data purification that needs to happen. So as requests come in, you have attributes. They need to be changed to field names. Resources don't necessarily correspond to rows. You have permissions. This is a big deal. The ACL could solve some of your problems, not all of your problems. Once you start to expose all of your data to the outside world, you need to really heavily think about how you handle permissions down to the attribute and up to the resource. You need to deal with stateless authentication and authorization. Cross-origin resource sharing is kind of fun. When you have front-end clients connecting to you, you need to communicate with them in a way that they could actually consume that. Otherwise, the browser's just going to say, hey, we're going across domains. We don't like that. We're not going to allow it. And you really need to think about documentation. It's kind of one of the most overlooked steps, but it's extremely important. And you need to think about how you're going to generate that and keep on top of it in a way that's going to be sustainable. So I mentioned this, but API schema is not the same thing as database schema. Resources are supposed to be easily consumed by an API user, and that often means giving them a lot of related data, sometimes not giving them attributes that exactly match the fields in your database. So what we came to find and accept is that models aren't just for tables. In a traditional app, the models generally represent a table. But when you're building out a CakePHP app that's meant to serve out a REST API, your model should actually match the tables for your backend logic, but your resources for your front-end API consumers. So we have models representing those resources in our app. The new strategy for us was we share models when possible. So if there is a resource that happens to just map cleanly to a table on the back end, we use the same model to do that back-end logic and the front-end logic because chances are it's very similar. We created brand new models for resources that were only meant to be consumed by a front-end API consumer. And we set up a bunch of attribute and relation configurations on those models, which basically give the API instructions about how those should be served out and how those should be input back in. So this is just an example. We have an attributes array at the top of every model that acts as an API resource. And it basically gives the API some simple instructions about what it's supposed to do with these attributes. So a few things that you wouldn't normally see coming from the Cake core in a backend app, but that are applicable to an API, like whether or not you should be able to sort on an attribute or query by an attribute. The descriptions are actually used to automate, to generate automated documentation. Here you see request equals relation. We actually use that as a way to specify whether or not that attribute should be output by default, depending on whether it's a relation or not. Here are the relations. It's the same ones you're used to in Cake, but we actually just add a few parameters to them. So request equals true means that that relation will not be output by default. Require equals true means it will always be output no matter what. Include deleted, we use the soft delete in the utilities, and that means that even if the user itself has been deleted from the system, it will still get output with certain API resources. You start to find that that's really important when you build an API because you still want to give the front end some information, like the username who created something, even if that username doesn't actually exist in the system anymore. So how do we deal with input and output processing? So we have a model for every API resource. We now have information about the attributes and the API resource outputs based on those configurations I just showed you. We have information about the relations each HPI resource relies on by default versus what's requested. And we use this to input and output data automatically. We have an input data component and a query component which handles these things. So the first thing that the input data component does is it translates API attributes that are coming in to field names that it should actually save on the back end. And when processing the request, it converts that information into something the tables can understand and accept as inserts or updates. Converting options to integers is also something we found really needed to be done once you exposed an API. For an API to be intuitive, the user wants to see something like that. Status equals complete. That's also how they want to pass information. It's just easy to read. However, databases usually think like this. Integers. They're easy to sort on. They're quick to search by. So we don't compromise. We actually use the input data component to automatically translate those sorts of things. We also use it to honor typecasting. So what happens is ISO 8601 formatted dates go into the proper format that the database needs. False strings are converted to literal falses. Null strings are converted to literal nulls. So that's kind of important because a lot of times you have JavaScript apps that are communicating with your API, and they're talking to attributes that are booleans or nulls or that sort of thing, and they're actually passing you formats that don't match, but you know what they mean. They're passing you strings with null or false, and you need to be able to support that. It's easy to say, we're just not going to support that. You need to do the right thing, but in reality, if you're not flexible, clients don't want to work with you. It also integrates foreign keys. So here's an example from WizeHive that should be easy to grok. So we have forms, and you could save forms, get forms, etc. And that's a parent level resource. It's very important. And then we have sub-resources. So forms can have records, and that's how you access them. So the problem is that when you're saving a record, you don't want the user to have to specify a form ID that's already in the URL. So the input data component automatically figures those sorts of things out and gives the table the form ID, even though the user never actually passed it in the post data. It also brings in denormalized data. So a form belongs to a workspace in WizeHive. A record belongs to a form. But we want to store workspace ID information in the records. It just makes it easier for us to do things on the back end. Again, you don't want the user to have to send you that information. So the input data component automatically figures that out. So then there's the other side of things, the query component. And it basically just does the same exact things in reverse. So the idea is that the query component is taking everything an API user wants to do, like use strings like status equals complete, not have to pass redundant information, and it's translating that for querying, and the input data component is doing the same thing, except it's translating it for saving and updating. So another thing that we really struggled with for a while was permissions. They can get really, really complicated, and the Cake ACL is less than optimal for all scenarios. So the ACL is great for static permissions. And what we found is it's not so great at handling variable permissions. And we kind of always knew that from the work that we used to do with CakePHP, but when we needed to develop an API where every last piece of data in the system was accessible from the outside, that problem just exacerbated. So what's the difference between the static and the variable permissions, and how do we reconcile that? So static permissions have app-wide groups. This is the type of stuff you're used to in most apps. You have default users, admins, root users. And they allow or block CRUD access to an entire resource or a resource's attribute. So we use the ACL to do these sorts of things in our API app. We have a forms controller. We're allowing all access to it as a default user. We have a for model. We're listing out the attributes here. We're saying what you're allowed to create versus read versus do anything to, etc. And it's great for that sort of stuff. It's very static, and it's not even hitting the database. It's just using these arrays, which is great. So then you have dynamic permissions, and this is where things get more interesting. So what do I mean by dynamic permissions? Well, a lot of times your ability to do something is specifically limited to the existence of some other information in the database. So it's not this app-wide rule, like if you're a default user, do this, if you're an admin user, do that. It's more like if this piece of data is in this state, then this other piece of data is allowed to do something else. So a good example of that in WizeHive is that we have workspaces, and those workspaces have owners, members, etc. They're static within the context of the workspace. They're kind of like the app-level permissions in that sense. However, the workspaces themselves are dynamic. You basically have row after row in the database of workspaces, and so what you're having to do is look up whether or not somebody is a member in a workspace in order to get to some other permission. Just to be clear, the ACL does let you do that kind of stuff. It's not like you're limited to it. It's just that it's not very good at it because you need to store a lot of redundant information, do a ton of database queries, and it doesn't end well. So we came up with something called the permissions component to handle this for us. We have a few methods. Can create, can update, can you guess the next one? Can delete. And I think the most interesting one, require conditions. So what require conditions does is the API consumer gives us a set of attributes that they might want to query by on any given resource. And what we need to figure out is, are they actually allowed to do that? Are they allowed to view the things that they're querying by? And so the permissions component essentially gives us back a safe array. It processes what they've asked for. It also limits by things that they have not asked for. And it gives us an array of conditions that will specifically output a set of data that we know they're allowed to see. So we have the model as the go-to source for all of this permission information. And those methods I just mentioned in the permissions component actually map to these methods in every model. Is user authorized to create, update, delete, And then the magic one, user is authorized to read some field name. This returns an array of values that the user is allowed to query by. So essentially what happens is, if I am doing a query on workspaces in WizeHive, and I say I want back workspaces where the ID is 2, 3, or 4, what we need to actually figure out is, that's great, but is the user allowed to view workspace 2, 3, and 4? So in the workspace model, there might be a method called user is authorized to read IDs. We're going to get a list of IDs that they are a member in. We're going to output that. The permissions component is going to do an intersect, and it's going to say, well, actually, they're just a member in workspace ID 2 and 3, so we're going to modify the query and take 4 out of it. So essentially, it still gives them back what they asked for, but it's just limiting it by what they're actually permitted to see. So these are just, this is just an example of what I just mentioned. So another thing that you need to deal with is authentication and authorization, and you need to kind of make some tough decisions. There are a lot of protocols out there, a lot of different ways to go about it, and you don't really want to make the wrong move. So what we found is that there are a lot of costs and benefits to each protocol, and you could kind of drive yourself mad trying to pick one. At a certain point, you just need to ask yourself what your unique business requirements are and who your users are and what your security constraints are, and pick the one that makes the most sense for your service. So what we went with, and I'm not going to get into that because it could be an entirely separate talk, but we decided to go with OAuth 2. At a high level, we went with it because it's simple. It accommodates many different types of clients, specifically front-end clients who need to be able to access private information without creating secure hashes in real time. And it is being adopted by some major providers, which gives you a little bit of comfort that it's not going to just disappear. So the simple version of OAuth 2, how does it work? Well, you basically have your two-legged flows and your three-legged flows. Your two-legged flow is that when somebody is trying to get a public resource, you just authenticate their client ID, their secret. You say, great, it matches. We're going to provide that to them. It doesn't have anything to do with a specific user credential or permission in the system. It's just saying, yes, you have an API client. You're allowed to view any public data. A three-legged flow is basically the API consumer acting on behalf of a user. So the API consumer has an access token. That access token maps specifically to user John, and that API consumer is allowed to get information and save information on behalf of John, and that's a three-legged flow. And as I mentioned, you use an access token to sort of identify people in those flows. So what are the challenges? Well, the clients need a way to get and refresh access tokens, and you need to be very careful with how you handle them. That access token is your key to everything in the same way that a cookie identifier matches you up to a session in a more traditional app. And the app needs to authenticate the user with every request. It's stateless. That's one of the primary foundational elements of REST. It's got to be stateless. So we developed an OAuth 2 plugin for Cake. And there's a lot to it, but what it comes down to is that there's an OAuth 2 controller. It handles all of the client's token getting and refreshing needs. So what that includes is authorize, grant, and token. Basically, these are just different ways to interact with the system so that a client can say, I want a token, or I have a token, and I want to verify that it's good. The OAuth 2 authenticate class is an adapter which logs the user in on every request. So this is sort of your magic class which keeps your app stateless. It will look for the access token on every request. If it's there, it will essentially do the login logic that you would do one time in a more traditional app on every request and make sure that that user information persists throughout the request. So the configuration is really simple. You have an access lifetime for the access token, the refresh token lifetime. You tell it what the name of your user model is, username, password, blah, blah, blah. So very simple, as you could see, and it just works. So I mentioned cross-origin resource sharing before. That's another challenge. API calls are often done from front-end apps. And the problem is that if you're on domain b.com and the API is on domain a.com, the browser will just throw a fit and say, we can't communicate cross-domain without you sending and receiving the proper headers that let us know that it's OK, that you intended to do that. So Cake doesn't have any default options to handle cores. So what we did is we developed a dispatcher. It uses the Cake 2 dispatch filters. Essentially, if a core's request header comes in, we give them back the core's response headers back. And it's that simple. The front-end app just accepts that, and you're allowed to go cross-domain. It also immediately stops propagation on the options request. If you're not familiar with cores, an options request is basically just a way for the front-end app to make sure that it can access some other domain before it sends the full request. So then there's documentation. It should be as dry as possible. You don't want to be documenting a bunch of attributes and resources and routes that you essentially have in your models and routes and all these other configurations. But at the same time, you don't want to sacrifice usability. You want somebody to be able to browse your documentation and actually read some plain English descriptions about things and be guided through it in a way that makes sense. Interactive documentation is better, we found, a way to actually read what a resource is supposed to look like, but also try it. So we chose Swagger UI for that. If you're not familiar with this and you're developing APIs, I highly recommend checking it out. It's basically just a system that is built for interactive REST API documentation. So how do we keep it dry? Well, we developed a doc shell. It uses a combination of our routes, models, attribute configurations, permissions, validation rules, and it takes all that and it puts it into a bunch of JSON files that Swagger UI can understand. So with literally zero effort on our part, we have a fully documented API with no duplicated knowledge. So how do you keep it user-friendly? Well, sometimes a resource dictionary isn't enough. You can't just tell somebody WizeHive has workspaces, forms, here are the attributes. It doesn't really make sense to them. They need to know what is a workspace, what's the paradigm, how does this all relate to each other? So plain English descriptions help. So what we do is we have two descriptions that could be used. One is attribute level. So if you want to tell somebody something more about a workspace name that they should know, you could write the plain English description in the model where all your other attribute information is, and the documentation will automatically latch on to that. You could also put files in a folder structure that we have a convention for, and essentially what that will do is look to see if there's a file for workspace, and if so, output that as plain English descriptions for the workspace. So what are we missing? Well, there's JSON and XML formatting, error handling, routing, versioning, caching, links, rate limiting, monetization. So what you find is that it never really ends. There's always something you're going to want to do better with your API that you see other companies with 100 times more resources are doing with theirs, and you don't have time for everything. So again, it comes down to needing to think about your business goals, trying to stay as in line with standards as you can, but picking your battles. And it's also worth noting that you can outsource some of these functions. So rate limiting, monetization, caching to an extent. There are services like 3scale.net that can actually add a layer on top of your API and do those things for you. So nearly everything we've used to build this API is now open sourced as of today. That repo essentially contains a demo application. It's a blog app, which is useless. You'd never actually want an API for your blog, but it's just a nice little example. And it uses plugins that we've developed which power the entire API. So you could kind of see how the comments and the posts and the users relate to each other and how they use these configurations and plugins to serve out a full API. So one last thing before I finish up here. I wanted to actually show you the API in action a little bit, just so you could see from a user standpoint how this looks. So this is a sample OAuth page. It's using the OAuth plugin in our API app to authenticate a user. So I'm going to create an account. So you'll notice this is all happening via the OAuth plugin. No effort required on your part. So these things you see everywhere, allow access, no thanks, that's just part of the plugin. And you could style this however you want. And there we go. So the sample page just came back. It gave us a token. Now we're able to identify this user. So let's do a little hello world here. We have this handy method in our API called users/me. If you throw a token at the end of it, it will do exactly what it sounds like it should do. Or not. I changed something right before the talk. Anyhow, so what it will do is it will actually give you back a JSON object with your user. So it's going to tell you what your user ID is, things that you wouldn't normally know just by logging in. But now that you have that ID, you could do other things with it. And as long as you have that access token, you can make any requests on behalf of that user. So I encourage you to clone that GitHub repo, give the API functionality a shot. A lot of it is highly reusable, so if you just want the OAuth part, but you don't necessarily want to do the API our way, that's fine. You could use that. But if you're starting out with a project where you need to just develop a REST API from the ground up, it's actually a great framework. Any questions?
Can you show off the Swagger UI?
Yeah. Actually, my Wi-Fi is off right now. There was another question, though, while I'm doing that?
Yeah, looks pretty cool. I'll definitely look into the source. Do you expose just CRUD functionality, or can you expose any other methods too?
For the permissions, or? Oh,
In the API.
right. So it works off of controllers. And so what happens is a controller usually maps to a resource. Every once in a while, you might want to create a verb, and you could create a controller specifically to do that more specialized logic. You want to stay away from that because it's not particularly RESTful, but you can do it. Yeah?
I was curious to know, when you were mentioning the permission component, I just wasn't sure, does it modify the query when it comes from the request to the model? Does it modify the request, or does it make a request to identify if that particular user has permission to do that?
Both. So what it's doing is it's actually reaching out to the model. It's saying, what does the user have access to do? Sometimes a query might be figuring that out. Sometimes you could figure it out without a query. But regardless, it's passing back a bunch of information about what the user is allowed to access. Then it sends that query over to the actual resource on the back end, and it's essentially pre-filtered at that point.
Okay, so then that leads to my next question then. What database are you guys using Because it sounds to me like there's a lot of calls back and forth,
Mm-hmm.
even on a single request.
Yeah.
Especially when it's going through all these layers to actually identify whether or not that data is available or accessible by the request.
So what you'll find is that when you have really, really complex permissions, there is very little way to avoid that. What we have is actually doing tremendously less queries than what you'd get if you were using the Cake ACL system. So it's better in that regard. But you also have to be smart about caching. A lot of permissions a lot of what a user is allowed to do can be cached. So for example, what workspaces are you a member in? That rarely ever changes. Just cache it. So a lot of these query modifiers that help the permission system are highly cacheable. And so at the end of the day, you don't actually end up doing that many queries. I'm going to try to pull up a development version of our documentation, but I have not looked at it in about a week, so I make no claims. Yeah, so this is Swagger docs. So basically what happens is you just put an access token in there that you want to demo by. You open up the resource. It gives you a full list of what you could do. There are all the attributes. That's what I could query by. And I could actually hit try it out, and I would see a JSON response there. I can't do it right now because I don't have the access token.
So the conventions that you have on the CakePHP side builds the JSON, and then Swagger builds all this for you?
That's right. That's right. So all you need to do from the Cake app is generate a really nice, clean JSON model of your documentation. And then Swagger reads that model, and this is all Swagger. We've styled it a little bit, but most of the work is done for us. All set? Yeah.
So it looks like you have a number of custom plugins in your demo app. Are those documented anywhere?
I literally just pushed this up a few hours ago. So we don't have much documentation yet. What I did is I knew that I wouldn't have enough time to get documentation in there that would be highly helpful for this talk. So I actually put together that entire demo application last night. So what should be helpful is if you're interested in this, download it, look at the demo application, and it'll tell you a whole lot about how the system works just by looking at those few models. All right, thank you.